Yes. Okay, so let's now begin. Sorry, let me check first my mirroring. I don't know why. Okay. All right. Yeah. Yeah, I think it's just important that I be clear with the power. Yes, it's the power rule of exponents. Yes. When we said, sorry, I don't know why it doesn't. Let me try this again. It was working well a while ago. Okay. So when we had A, B, no, sometimes technology would, okay, let me erase. All right, do it again. Hmm. It's erased there, but it is not erasing in my, let me first stop share. Let me restart my iPad. Looks like it is, mhm. Okay. All right, let me try again. Hmm. I was practicing a while ago and then it is not working now.
Mm.
Mhm. All right, I think I'm okay. So I was talking about the power rule of exponents, saying that AB squared is equal to A squared B squared. Yeah, that one is of course only applicable, which I mentioned in some of my comments on what you have done. That is, it is not used when you are using addition or using subtraction. Okay, they are not equal. So a minus b squared is not equal to a squared minus b squared. All right. So just, I think we would be able to, we have seen that the answer would be different because like when I say 7 squared minus 4 squared, and we talk about 7 minus 4 squared. These two are actually not equal because 7 minus 4 squared is actually 3 squared, which is 9. While 7 squared minus 4 squared is 49 minus 16. And these two are totally really different. So it's just important that we are clear with this, so we don't we don't use a certain rule. So that rule is only for multiplication. Um, and I hope that that had been clear to each of us, that that is the case. So it's actually just a very simple thing that sometimes we would think that that is so, because really we talk about a times b, that's different from a plus b and a minus b. Well, of course, that is applicable also to A over B. So these symbols in math are very, very important. That the multiplication, division, addition, subtraction, and sometimes we just maybe looking at A times B, we would write it as A plus B. So a change in symbolism will mean a big difference in the answer. So we will be in our discussion later on, which I think you would remember in your high school algebra, that we can square a binomial. When I say binomial, there are two terms like a plus b or a minus b. But ab or a times b is just one term, which is a monomial. So that's why, or a over b. So the rules for multiplication in this case of the laws of exponent would not apply to addition and subtraction. So with that, I think I just want to emphasize that in math, we are very, very careful about little things, because mathematics illustrates the importance of little things in the symbolism in math. Just a certain difference in symbol, even the slightest error can make a great difference in the answer. And I just want to relate that to life, because if we have small faults and these are uncorrected, they will make a vast difference in our character. So if there's a great difference in the answer in life, we need to correct immediately the small faults that we have seen. All right, so I just want to emphasize that in our solving problems in math, and of course even in other in our real life, accuracy and precision is very important. So just want to remind, sometimes also we copy the problem and we're not very careful, we copy differently. Although of course when that happens, I would just compute your answer based on the problem that you copied. But it's always good that whatever is the problem given, that's the one that we will solve. And copying it in a different way would, of course, you can solve that correctly, but you'll have a different problem than the
Yep.
other students. Yes. Yeah. Okay. So, wow, I just want also to emphasize, this was also emphasized by Ellen G. White in Messages to Young People, very much to young people as you are. And she says, never underrate the importance of little things, because little things supply the actual discipline of life. And it's by them that the soul is trained, that it may grow into the likeness of Christ or bear the likeness of evil. So, says God helps us to cultivate habits of thought, word, look, and action that will testify to all about us. that we have been with Jesus and learned of him. So little things in life, they're really very important. Little action that may also influence other people. We have to be very careful on doing that. Yes, and yeah, so before I just keep moving on, so we will now look more onto the radical expressions. Okay, more on this. Um, when we had your answers to your problem to the to problems that I have given to you, we allowed you to have uh, a radical in the denominator. Okay, it's like, so if your answer is 2 over the square root of 3 over 3 the square root of 10, you will say, well, that's the final answer. If you have a 4 over 1 plus the square root of 5 in the denominator, if that's, an expression at the denominator with a radical, we just allowed it to be so. However, we want the denominator, I mean, the radical expression to be simple in its simplest form. And that is, it says, if it does not contain a radical in the denominator. So that's what we will be considering today. We will be learning how to write radical expressions in its simplest form. Okay. So looks like I am not, let me check because I am not seeing anyone in my, okay. Yes, all right. So let's do that. And there are two ways how to write radical expressions in its simplest form. And we call that rationalizing the denominator. And so rationalizing the denominator, if you have just a term with a radical in the denominator, we want to remove the radical right there. And I think you know that if we multiply square root of 10 times square root of 10, what will be the answer?
Are we supposed to be seeing your shared screen or no?
Oh, I'm sorry about that. I am not sharing. Let me check. I thought okay, let me discard. Sorry about that. So even when I showed, looks like I deleted the shared screen. Okay. Yeah. So I was talking about all this and let me see. Okay. Thank you. Please, as soon as sometimes that really happens. Oh, okay. Sorry. All right. So I was having that a while ago on the symbolism and okay. Yeah, and what Ellen G. White mentioned on Messages to Young People, page 203. Okay, so let me proceed. Okay. Yeah. So I was talking about rationalizing the denominator. When we want the denominator not to have a radical. So I was saying, if I talk about the square root of 10 times the square root of 10, what would be our, the square root of 10 times square root of 10, what will that be? Square root of 10 times square root of 10. Okay, I think we have considered this as the law of, the product rule. So square root of 10 times square root of 10 will be what?
10?
Yes, all right. Reason is because that's actually the square root of 100, correct? And the square root of 100 is 10, right? In other words, if we want to not to have a radical in the denominator and you have a single term, one way of doing that is to multiply the numerator and the denominator by that radical in the denominator. All right, so I would say if I have now 2 the square root of 3 divided by 3, the square root of 10. To remove that square root of 10 in the denominator, I multiply by square root of 10 over square root of 10, right? Reason is, why do I have to multiply numerator in denominator? When I multiply by square root of 10 over square root of 10, it is the same as just I am multiplying the whole term there by 1, because square root of 10 divided by square root of 10 is equal to 1. And anything you multiply by 1, that term on the left doesn't change because I'm multiplying by 1. It's still the same as 2 the square root of 3 times 3 the square root of 10, because I just multiply by 1. But we're doing that because we want to rationalize. In other words, we don't want the radical to be in the denominator. So if I multiply 2 the square root of 3 times square root of 10, that will be 2 the square root of 30, right?
30.
Yeah, because we say we multiply the 1 under the radical. 2 the square root of 3 times 10. Then what happens to the denominator? 3 the square root of 10 times the square root of 10, what will that be?
3 times 10.
All right. So that is just the same as 3 times 10. And therefore, you'll now have 2 the square root of 30 over 30. Now, don't be tempted to cancel 30 and 30. The one on top is square root of 30. The one in the denominator is 30. So don't immediately say, oh, they are the same as 30. I can just remove them or cancel them and make them 1. They're totally different. The square root of 30 is not the same as 30. But then you still can simplify because there's a common factor between 2 and 30. And what is that?
15.
2 and 30.
2.
2,
2.
yes. 2 can be divided by 2. 30 can be divided by 2. And therefore, what will be our final answer? It will be just
Square
the
root of
square root of
30
30 divided by
over 15.
15. Yes, because we divide 2 by 2, that's a 1. 30 divided by 2 is 15. So your answer should not remain as 2 the square root of 3 if ever you do computations on radicals, and you'll have your answer as 2 the square root of 10 over 3 the square root of 10. You still need to move on by making it simple. Put that in its simplest form by what we call rationalizing the denominator. So this is what it is in this, I said, rationalizing the denominator means to perform some operations to remove the radical from the denominator. And so the rule, as I have there, is to multiply the top and the bottom by the radical in the denominator. And in that case, what happens is there will be no more radical in the denominator. The radical is allowed on the numerator, but not in the denominator. So that's it. So just multiply by the, whatever is the radical in the denominator, multiply that. And of course, have the numerator on that radical over the denominator, that same radical. So that is done when you are having just one term in the denominator. But now what happens when you have this term, 2 terms now, 1 plus the square root of 5. So would say, well, we can just the same as rationalizing the single term, that would be different because this is already, we call this a binomial, which I will be talking more later on when we go into the polynomials. So in that situation, look at, I have an explanation here. If the denominator has a sum or difference of 2 different radicals, we need to multiply the numerator in denominator by the conjugate to remove the radicals. Which is that our book has started talking about rationalizing the denominator with us not having discussed how to multiply binomials and so on. But definitely that one is making use of what we call the distributive property. But in the moment, so that it doesn't get so confusing using all this A, B, and whatever, let me just give an example using numbers. Okay, let me just give an example using numbers. So if I now have uh, 3 plus 1 and a 3 minus 1. Okay. So if I multiply 3 plus 1 times 3 minus 1, that is actually, if you just immediately add 3 plus 1, that is 4, right? 3 minus 1, that is a 2. And 4 times 2 is 8. All right? So 3 plus 1 is 4. 3 minus 1 is 2. So I have now, I am multiplying binomials such that they have the same numbers, but different, but opposite operation. One is a plus, the other is a minus. But isn't that 8 is the same as 3 times 3 plus 1 times minus 1? Okay, now what did I do there? I multiply 3 times 3 and I multiply 1 times minus 1. So now you have 3 times 3 is 9. 1 times minus 1 is minus 1. So that is actually now 9 minus 1, which is equal to 8. Now, I'm just doing this. We'll talk more about this when we multiply binomials in just maybe a few slides away. But rationalizing the denominator by multiplying by the conjugate says they have the same values, except that one is plus, the other is a minus. Okay, so just if I am talking about 3 plus 1, the conjugate of 3 plus 1 is 3 minus 1. So that if I multiply this term by its conjugate, if the term is 3 plus 1, the conjugate is 3 minus 1, it is just the same as squaring the first term, or 3 times 3, squaring the second term to 1 times 1, and subtract, because 1 times negative 1 is negative 1. So that is now 9 minus 1. So the misconception in the homework the other time, where when I have 7 minus 4 squared, that you square the 7 and you square the 3 and subtracted, that is applicable when we're dealing with conjugate. That is when the sign of one is the opposite of the sign of the other. So whenever we multiply by the conjugate, the way to multiply is just square the first term, 3 times 3, and square the second term and subtract. Well, the explanation here is like that. We'll talk more about that later on, but that's the idea. Just multiply by the same numbers or the same terms, except that if one is a minus, the other should be a plus. If one is a plus, the other should be minus. Okay, so with that, then maybe we can apply this in the 4 over 1 plus square root of 5. All right. So I have a 4 over 1 plus square root of 5. So we want to simplify this. So according to the rule, we will have to multiply by the conjugate. Okay. So what will be the conjugate?
1 minus square root of 5.
Yes, 1 minus square root of 5 over 1 minus square root of 5, right? So what will happen there? Now we can distribute the 4. So 4 times 1 is 4 minus 4 the square root of 5 will be 4 the square root of 5, all right? Divided by, then what do? We square the first term, 1 times 1, all right? You multiply 1 times 1, that's a 1. Square root of 5 times square root of 5.
5.
Yes, that's a minus, right? Okay, so 1 minus 5. Right. So, well, actually, I should have the one at the bottom is a minus 4. But anyway, that will now be, let me just, perhaps it's better to do this first this way so that before we distribute, because sorry. All right, okay, just for a while, let me erase. Sometimes that's a problem with, okay, let me erase that 5 there. Okay. Right. So 4 times 1 minus the square root of 5, all right, before even distributing. Divided by 1 minus 5 is? What's 1 minus 5?
-4.
Yes, that's -4. Okay, okay. So I think in that situation, we already have, there's a 4 at the numerator. You divide that by -4. What will that be? What's your final answer?
4 minus the square root of 5 over, no,
No, yeah, but there's a 4. You see, there's a 4 there, and another 4 here. Can we not divide them? 4 divided by -4 is 4 divided by -4.
-1.
-1. All right. So that's actually -1 times the 1 minus the square root of 5, right? Because this will cancel that one, right? So 4 divided by -4 is -1. And multiply that by 1 minus the square root of 5. And therefore, what will be the final answer? You remove that -1 now. Okay, we multiply. -1 times -1 is -1. -1 times -5 is plus, correct?
Yes.
Yes. My writing. 1 minus 1. Okay. So -1 plus the square root of 5. All right. So let's go over that again. The first thing we do is multiply by the conjugate, where the sign, just have to change the sign of the middle term of that original 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 term. Okay, and then we just square the first term, square the second term, and then you get a value that has no more radical, and then we simplify. Okay, so maybe let's just, all right. So that's actually what I was, okay. So the conjugate of two terms is just the same two terms with the opposite sign in between the terms. All right, so just multiply by the conjugate. So that was what we explained a while ago. So let's try an example once again. I have now 5 the square root of 6 over the square root of 2. Please write this in its simplest term. So maybe we can just do this together. What do I do? This one is a single term. What will I do with that? What will I multiply?
You multiply both the top and the bottom by
Yes.
itself.
By itself. Good. All right. Okay. So therefore we have 5 the square root of 6 and square root of 2. So you multiply the coefficients. That's 5 times, it's understood that the coefficient of square root of 2 is 1. And multiply the 1s under the radical, that will be square root of 6 times 2, correct?
Yes.
Yes, good. And what will be at the bottom? Square root of 2 times square root of 2 is?
2.
2, yes. Now, you did this in your assignment that you just would, some of you have submitted. Okay, the others will submit maybe a little later. How do we simplify more square root of 12?
By
Is it-
finding a perfect square.
Yes, factor a perfect square from from 12. And that is 4, correct? Times 3.
Yes.
Yes, good. Over 2. And therefore, this will be What's the square root of 4? So it's actually the same as 5 times the square root of 4 times square root of 3 over 2. And the square root of 4 is 2, correct?
Yeah.
Times square root of 3 over 2.
Two.
I think 2 and 2 can be divided. What will be our final answer?
There's 5 times the square root of 3.
Yes, that's 5, the square root of 3. That is now your answer in its simplest form. So the 5 square root of 6 over square root of 2 is now changed to its simplest form to be 5, the square root of 3.
You would also
But
be
there's
like this to
another way
say
of doing that, yeah?
I did it.
Okay, so
say
what's
10
there's another simple way of doing it, correct?
Yeah.
Yes?
No, I mean into getting the answer to just divide because you already know that root 4 is going to be 2. So you just multiply 2 and 5 and it's 10. So 10 divided by 2 is 5.
Yeah, that can also be done. Yes. So doing mental math. In other words, you just say square root of 4 without moving on to 5 the square root of 4 times the square root of 3. Of course, I just had to do that to show that we have what we call a product rule. Okay. But you can just immediately divide. The square root of 4 is 2. Divide by 2. And then, but there's another way looking at 5 the square root of 6 over the square root of 2. As far as this problem is concerned, using the quotient
That's
rule. Do you remember
Use-
the quotient rule?
It's 5 square root of 2 times 3 over square root of 2, and you cancel out the 2's.
Yes. And that is also 5 the square root of 3. You see that?
Yes.
Yeah, so there's a long way making use of course it's not always the case because it just so happened that 6 and 2 you can divide. All right? And it's a perfect, you can divide 6 by 2. But there are times when you now have the square root of 6 over the square root of 7 and you cannot get now the square root of the denominator, or maybe the denominator maybe a little bit bigger than the numerator. But in a situation where you have a problem and then you remember some of the rules that you may apply. Okay, so it may not be necessary to multiply by the denominator by itself. Rather, you can just remember the rule that you have learned before. So in that situation, that is true. So you can also use what we call the quotient rule. So there are two ways. One is the longer way. The other can be a shorter way. That just be reminded of some of those rules. And if those rules are applicable, then apply. So there are several ways of doing so, and that's one nice thing, all right? There's are always different ways to solving a problem. There are those that can take you long, but there are times when you do it long, there are more experiences in the process, okay? Yeah. The other one is just, direct when you are given the intuition that that's the best way to do, and making just a rule that immediately you get the answer. So that's now, so I gave that example to show you that there are different ways of doing those. So your answer remains the same, of course, whatever, as long as you do the process correctly. Yeah. Now this time, let's have, okay, this one. 7 over 2 minus the square root of 3. Will you please do this? Okay, I want you to remember your conjugate.
The conjugate is 2 plus root 3, right?
Mm-hmm.
Oh, you said we should do it?
I think so.
Do it, yes, do it. And then give me the answer. Mhm. Got the answer?
I got 14 plus 7 square root 3.
Okay. 14 plus 7 root of 3.
Root of 3.
Then you all got the same answer?
That's the answer I got.
So 14 plus 7 square root of 3.
Yes.
Yes.
Is that the correct answer?
Yes. So did all of you get the answer? Yeah. It just so happened that the 2 minus the square root of 3 times 2 plus the square root of 3 is a 1, correct?
Yeah.
Mhm.
Yes. Yeah, because it's 4 minus 3. So now we're just multiplying the numerator by the conjugate, which is 2 plus the square root of 3.
Yeah.
Yes. So 7 times 2 is 14, and then multiply plus 7 square root of 3. Everyone has gotten the correct answer?
Yeah.
Yes, all right. So we don't need to. So sometimes, some mental math can actually be done if you have that kind of thing. Yeah. You're like, oh, 2 minus square root of 3 times 2 plus square root of 3 is 4 minus 3, which is equal to 1. So I just have 1 in the denominator. So I'll now have 7 times 2 plus square root of 3. And therefore, it will be 14 plus 7, the square root of 3. So that's what it is for dealing with conjugates. So it's either, if it's a single term, just multiply by the same figure at the bottom of the denominator, but it should be multiplying that numerator of the numerator as well as the denominator. And then the other one is the conjugate. Okay, so if there's no question on that, then I guess that's what it is. We want always things to be in its simplest form. So this is one way of simplifying radicals. Okay, so let's just proceed. I think that one is just a simple, you have done that maybe already in the past, and maybe you'll have some homework for you to be able to do that. Okay, now we dealt with square roots, but it's not only square roots. We can also find cube roots, fourth roots, fifth roots. Okay. Yeah. So we now talk about certain A with at least one nth root. Then I already told you that the principal nth root would always be the positive root. Okay. And then the one that has the same sign as A. So just some terminologies. If it's not whenever we deal with the square root. Okay, let me just emphasize this. Yeah. When we talk of the square root of A, it is understood actually that the index is a 2. Reason is because we're saying that what number will we multiply by itself 2 times, and we get that value inside the radic sign. So we don't just put the 2, but it is understood that it is a 2 because we're multiplying the root twice to get the radicand. If I say cube root, then it's understood that the index is a 3 because the cube root means that I multiply the number 3 times by itself in order to get whatever is the radicand. So the cube root of A, the 3 is the index, radic sign, of course, is your radical. Then the radicand is the one under the radic sign, and your cube root is the answer. So there are different cube roots. Maybe you just have to remember because we will be having some values, and you will extract the cube root. When you say we multiply 1 3 times by itself, it will be a 1. So if I talk about 8, The cube root of 8 is 2. Because I multiply 2 3 times by itself, I get 8. The cube root of 27 is 3. Because 3 times 3 times 3 is 27. The cube root of 64 is 4. Because 4 times 4 times 4 is 64. And the cube root of 125 is 5. Because 5 times 5 times 5 is 125. All right. Now, so similar until 216, the cube root is 6. 343, the cube root is 7. 5112, the cube root is 8. 729, the cube root is 9. 1000, a cube root is 10. All right. Those are some common, yeah, from 1 to 10. We can also extract the fourth root. Okay. So when it's fourth root, then the index is a 4. So if I say, what's the fourth root of 256? What number will you multiply by itself 4 times and you get 256? Anyone?
64.
Think of a number that you multiply 4 times by itself, you get 256.
Four?
Any
Okay.
guess? That number multiply 4 times by itself.
4.
4, all right. Because you see, 4 times 4 times 4 times 4. Okay, we can just say that's the same as 16 times 16, correct? And 16 times 16 is 256. The square root, of course, of 256 is 16. But the fourth root of 256 is 4. Yeah, so that's it. Anyway, so those are just what we call nth root. You can move on to fifth root and sixth root and so on. So the idea only is whatever is the index, that is now the number of times you multiply the root by itself to get that number under the radical sign. Okay. So we can change. So as I mentioned, we talked about square root. It's understood that that's the 2 there. So according to, we can change your radical into radical expression into having rational exponents. And it tells us if I have the square root of 2a, that is actually just the same as a to the 1/2. Okay, so it says determine the power by looking at the numerator of the exponent if a to the m over n. So the square root of a is a to the 1/2 because that is it. Your denominator is actually the root and your numerator is the exponent. So that if I have a to the 3/2, how do I write that as a radical?
A squared to the third exponent.
Oh, it's a square root of a cube. Is that it?
Yes.
Yes. It's understood that there's a 2 there. Okay, but we don't put it anymore because it is understood that just without anything, it is already a 2. So a to the 3/2 will be the same as the square root of a cube. So your numerator in that m over n is your power of your radicand. And the denominator is the index or the, how you will be extracting the root. So just to, sorry, let me erase. All right. Okay. So just the same. So when I say it's not just the square root, if I say 8 to the 5/3, all right, that is the same as the cube root of 8 raised to the 5th power. Okay. So actually we can now have the cube root of 8. So the cube root of 8 raised to the 5th power, you can actually put the 5 there. but it's just the same as raising it to a power. Rather than raise 8 to the 5th power before getting the cube root, it's much easier when you just get the cube root of 8 first before raising it to the 5th power. So the cube root of 8 a while ago we said is 2, and therefore raised it to the 5th power, multiply 2 5 times by itself, then you get 32. So we can,
32.
yes, so we can from a rational exponent to a radical, and then we can simplify. Right? Okay. So let's write this expression in radical form. How do we write 2 to the 1/6? So you just say that, yeah, we'll just say it all together. What is that? 2 to the 1/6 can be written as?
Square root
We
2.
call it,
Okay.
okay. What will I put here?
What?
Yeah, it's the whatever is in the denominator. That would be the 6. So that's a 6th
And
root
2.
of 2. Okay, let me go back. Isn't that what we're saying? Yeah. If it's AM over N, your M is the numerator, that's your power. Your N is your index. Let's take note of that. Whatever is in the denominator, that will be your index. Whatever is your numerator, that's your power. So let's proceed. Okay. All right. Let's have 27 raised to the negative 2/3. What will you
3
do?
root exponent -2.
All right.
Out of
I think the first thing we need
six.
to do is make sure that you don't have a negative exponent. So what do you do when the exponent is negative? You remember in our discussion previously?
You yeah, you times.
You remember you put that down. Yeah, we said
Mm-hmm.
x to the negative 1 is the same as 1 over x, right?
Yes.
Yes.
Yeah, so please remember those rules, okay? So we are using those rules. So here, you first change, you don't want that negative exponent there, so you can put that as 27 to the 2/3. Right?
Yeah.
Mm-hmm.
Yes, okay. So now let's write that as a radical. It's just writing. I am not asking you to simplify. So it will now be 1 over, okay, put a radical. What will I put as the index?
3.
3, yes, good. Then 27 squared, right? Or that can actually, if you can also write that as the cube root of 27, and you can square if you wish to. But they are the same. 27 squared, cube root of 27 squared is the same as 1 over the square root of 27, the whole thing squared. Yes, that is a power. We call it the power rule of the exponent. Okay. Letter C. How do you write that? Just say it. Okay, so if the index is 4, say 4th root. If the index is 6, 6th root. If the index is 7, say 7th root. So how will you write letter C?
4 root 1000.
4th root of?
1,000.
exponent 6.
All right, 4th root of 1,000 raised to the 6th power. You can put that 6th power under the radical sign. All right, letter D.
Cubed root of 6 squared.
Yes,
Three.
cube root of 6 squared. Very good. All right. Okay, next. Yeah.
5 root 8.
Five.
5th root of
8.
8. The power is 1, so you don't put that 1 anymore because that 1 is understood. All right, 5th root of 8. How about letter F?
A 4th root of 3x cubed.
Okay, now, is that problem the same as okay, 3x to the 3/4? You're giving me an answer as, are these the same?
No.
No.
No, okay. Yeah, because in the thing on the right side, you're also extracting the fourth root of 3 cubed. But my problem is just 3x to the 3/4.
Oh, no. It's not.
Okay.
It's
So,
only for
you're giving me as an answer as the fourth root of 3x to the no. So how will we write that?
we're gonna write 3
Because these are not the
separately.
same.
Yes.
Mm. Yeah.
Yeah.
So it's 3 times.
Okay, so since they are not the same, all right. So what will now be your answer?
It's gonna be 3
3, yeah.
3
into bracket,
Yes, you can
then
just put like that. And then
4
fourth
4
x
and cube.
x.
cube. Are we okay?
Yeah.
Yes. So please
Yeah.
don't just immediately, yeah. So the 3 is outside there because that's not part of the one with with a rational exponent. So it will now be 3, the fourth root of x cubed. Okay. All right. Yeah. Okay, now let's have a different way. We want to write the expression with a rational exponent.
2
2 to the
exponent 1/6.
okay, 2 to the 1/6. Oh, I want it maybe okay, yeah, I'm not okay, let me see. I want to see you. All right, next, letter B.
2
2 to the
exponent
1/3.
1/3.
Okay, that's easy. 2 to the 1/3. Letter C. That's also easy.
Exponent
6.
1/6.
10 to the 1/6. Yes. Letter D.
2 exponent 5/4.
Yes, good. Letter E.
5 exponent 5/4.
Yes. Yay. Okay.
2 exponent 5/3.
All right. Yes. Okay, so I think that's easy, So from rational to radical, radical to rational. Right. Yeah, we will have a chapter on rational expressions. And so many of these, even rational exponents and all those kinds of things. So we will be making use of them in many of our discussions later on. Okay. So then we now end these things on rational, on radicals and those other simple things. And we'll now move on to polynomials. So I would, yeah, looking at I was too optimistic when I did my syllabus. Supposed to be, you should have done everything already the first 2 days or first 3 days. But then I realized we just need to first learn more about these essentials of algebra. So we now have polynomials. So I was just thinking maybe I'll just give you 4 quizzes or something like that, but that would mean quizzes that are long. And sometimes it's very difficult to remember when there are too many, what's that? Too many concepts learned. So I just thought maybe let me just give you about a 30-minute or 45-minute quizzes every now and then. And so I will give you, well, I hope it won't be too much. We'll be having just a short quiz on the simplifying algebraic expressions until the radicals, the ones that you did your homework 1 and homework 2, which I will be marking later. And of course, rationalizing the denominator by making your radical expression simple, as well as the rational exponents. So that I will have just a different quiz on polynomials and some of the things on polynomials. So on Thursday, we'll have that first quiz on those coverage of homework 1 and homework 2, including what we discussed just the first half of our class today, so that I separate polynomials so that you don't get too much information and that it can get so confusing. Okay, so we'll be doing that on Thursday, I hope. So I will not be giving homework to submit for Thursday. I want you to use your time in just reviewing all those principles kind of thing for our short quiz. The only thing that you'll have to work on would be your reflective journal. You now have your second reflective journal, and that would be involving what you have learned uh, in class last Thursday and what you are learning this today, including these things on polynomials. And I think I told you to read a certain portion of that article that I wrote on integration of faith and learning. All right, I mentioned that in the bulletin board. That read that and your reaction to that mathematics and the Bible as in your readings. So that will be what you will be including in your reflective journal too. So that's the only thing you'll be submitting, but no homework on anything. I just want you to do a little review of all those rules that will be applied as we move along with that short quiz. I'll not do many. I will just make to want to test whether we're clear with all of those rules, because whatever rules we have learned would be used in all of the discussions we'll be having in this class. So yeah, I think so. Let's just proceed for the next several more minutes. Let's be talking about polynomials. We learned about algebraic expressions last time, but we now extend that into polynomials with that kind of general form of a polynomial. A sub n, x to the n, plus, and so on and so forth. A sub 2, x squared, a sub 1. And so we learned that in our algebraic expression, we consider any real number that precedes the variable is a coefficient. We learned that previously. So when I have a sub 0 that has no variable, of course, we know that is a constant. And every coefficient and a variable with exponent is considered a term. You know how it is with algebra, we need to learn their language. Then there's such a thing as degree of the polynomial. And it says that the degree of the polynomial is whatever is the highest power of the variable. And usually when we write a polynomial, we always begins with the variable with the highest power. And so the degree is the highest power of, the variable. And that one with the highest power is considered to be the leading term. And the coefficient of the variable with the highest power is considered leading coefficient. So those are the terms: polynomial, coefficient, term, degree, leading term, leading coefficient. So I have shown there what is the leading coefficient. That is the number that precedes the variable with the highest power. The leading term is the coefficient with that variable with the highest power. And of course, the highest power is called the degree of your polynomial. Okay? Yes. So like I have 5t to the 5th minus 2t cubed plus 7t. What is the degree of that polynomial? The degree? No, I am into the okay.
5 and
So I'm yes, 5. Okay, so for this, I'm talking about okay. Yes. The degree is 5. What is the leading coefficient?
5.
5. What is the leading term?
5 t to the
To the 5th.
5th.
Yes, very good. How about the second polynomial? What is the degree?
3.
No, that's
Oh,
the
wait.
second. The 6p squared minus p to the 4th minus 2.
2. Oh,
What
no.
is the
Not four.
degree? What is the highest
2?
power?
It's four.
4.
4, yes. What is the leading term?
6.
What did we say? The leading term is the term with the highest power, with the variable that has the highest power. What is the leading term?
6
6p
p
squared.
squared.
Okay, now I was saying a while ago, supposed to be a polynomial in its general form, you should always begin with the one with the highest power. It so happened that in my problem there, I have 6p squared minus p to the fourth minus 2.
Yeah.
Well, if it were to be written as a general form, that could have been written as minus p to the fourth plus 6p squared minus 2, correct? We should always
Yeah.
supposed to
Yeah.
be beginning with the term with the highest power. But even when I don't do that, you should be able to identify which one is the highest power and which one is the leading term and which one is the leading coefficient. So with that I have rewritten it into its general form. What is the power? What is the degree? What's your degree of this one? This
4.
4. What? Yes, it's 4 because that's the highest power. 4. So I rewrote this up to that, where I began with the one with the highest power and have your exponents reduce. So I changed it to minus p to the fourth plus 6p squared minus 2. I hope I am clear with that. So that the degree is 4 because that's the highest power of your variable. What is your leading coefficient? What's the coefficient of minus p to the fourth? Okay.
It's one.
The
Minus
one with the
1.
highest power is the one that has the highest power is a p to the fourth minus p to the fourth. So you just concentrate on that. Don't look at the other terms. Only look at the leading term. That the leading term is the one with the highest power. So in this problem here, our highest, the one with the highest power is p to the fourth, right? There. That is now your degree. 4 is the degree. And this is supposed to be a leading term. That's why I changed it and wrote it this way, to make it as its general form. I hope I am clear. So now concentrate all your answers from this minus p to the fourth. So because that has the highest power, yeah? So what is the degree? No, just say it. Everyone talk. All right. What's the
4.
degree? 4. What is the leading coefficient?
Minus 1.
Minus 1. Because I said if there is no number, is understood to be 1. Correct? That's the leading coefficient. And so your leading term is minus p to the fourth. Your degree is a 4. And your leading coefficient is a 1 minus 1. Are we okay?
Yes.
Yes. So leading coefficient is minus 1. And then the degree is 4. Your leading term is minus p to the fourth. So it's not actually necessary to write it this way, as long as you know how to identify the leading term. So in this problem here, 10 plus 2x minus 4x to the fourth, 4x squared plus 3x cubed. What is our degree? This one now.
3.
Degree.
3.
Degree, yes, 3. What is the leading term?
3x cubed.
Yes, and what is the leading coefficient?
3.
3. Okay, everyone, is that fine? Yeah, all right. How about this last problem here? What is your leading term?
Negative x to the 6th power.
Yes. Negative x to the 6. Therefore, what's your degree?
6.
And what is your leading coefficient?
Negative 1.
Very good. So I hope those terms, please be very clear, because sometimes I would say change it into having the leading coefficient to begin with and so on, or the leading term, then with these terminologies, and I think we are good. So we're just trying to, okay, now. So, so we'll now talk about adding and subtracting polynomials. All right. So we now have those terms and with exponents, the variables, and so on. So the idea when we add and subtract polynomials, we'll first begin with adding and subtracting. The first thing we need, whenever we combine, the combination should be like terms. You combine like terms, then we simplify and write it in standard form. And when I say write it in standard form, always take note that the way you write is that your exponents must be in decreasing order. Always begin with the leading term with the highest power. Okay. So now, let's okay. So what do we mean by like terms? It says that terms are like if they contain the same letter variables and they are raised to the exact same power. So an x cubed and an x squared are not like terms. Reason is because even if they have the same letter variable, their powers are different. Even if their first number or the coefficients are different, as long as they are of the same letter and the same power, then they will be like terms. So we say 3a and 2a are like terms because they have the same a and raised to the first power, although your 3 and 2 are different. So coefficients can be different, but as long as your variables are of the same letter and same power. So therefore, the 3d squared y, 12d squared y, minus 2d squared y, d squared y, they are like terms because the d have the same power as 2, y have the same power as 1, and they are put together. So I say b8 for b8 minus 5b8 minus b8, they are all like terms because they have the same pH. Okay. Yes. So, just suppose I have now 12x squared plus 9x minus 21 plus 4x squared cubed plus 8x squared minus 5x plus 20. Okay. All right. So I just want to show the solution. Then we'll have some examples later on. All right. So there's only one for x squared, for x cubed, I should say. Yeah, only one. So I'll separate that. Then I combine the ones with the x squared. And that will be 12x squared plus 8x squared. Okay, let me do my laser pointer. All right. So I have 4x cubed as only one. So it's there. Then I have 12x squared and 8x squared. Yes, so I combine them. I have 9x and minus 5x, combine them. And then the constants. So therefore, we just combine like terms and put it in a standard form with the leading term having the highest power. So for x cubed, 12x squared plus 8x squared is 20x squared. 9x minus 5x is 4x. Minus 21 plus 20 is minus 1. So it's as simple as that. Just combine like terms and then add them or subtract them and then write in standard form. Okay. Yes. Well, yeah, I just want to remember that when we talk of combining like terms, yes, only though like terms seem to be very easy to combine. Yeah. And I think, you know, this, is it a cliche or whatever? Birds of a feather flock together. And someone says that is the gospel truth. That really those people who you know like that's the reason why you know the Bible is saying be not unequally yoked with unbeliever, right? And I think that's what that's the principle. because it's very difficult to be together with one who is totally different from you. And so just the birds of a feather would flock together. Yeah. And yeah, someone wrote, show me your friends and I'll tell you who you are. Reason is because when you're all together as friends, you tend to have the same same likes and dislikes. Okay, so you are like terms. So it's very important to choose good friends so that all of you will really be of the same attitude and that you are able to flock together. So just thinking of these like terms. So always remember that those are what we mean by like terms. All right. There may be a difference in coefficient, but the power and the variable would be the same. Now, so let's try doing this just for a few 1 minute or two. Work on it. You can actually do some mental math if you're able to. This one is subtraction. Let's have that number one there first. Okay, what's anyone who has an answer?
I haven't finished yet.
Yet. Okay, so I'll give you a minute. Okay.
Oh,
This is now subtracting 4x squared plus 6x cubed plus x minus 7 minus 2x squared plus 6x plus 3.
it will be 4x. No, it will be 6 cubed
6x cubed, yes,
plus
plus,
2x squared
yes.
plus 7x.
Wait, that is minus. You're subtracting. Okay, girl. You're subtracting. Minus.
Oh, yes, it's gonna be, yeah, it's gonna be minus 6.
Minus
And then, so it
5x.
will be minus 5.
Minus 5x, yes.
Minus 10.
And then, yeah, minus 10.
All right. Okay. So actually, you should have just written that to begin with, to take that out from the
Negative.
our
bracket.
parentheses. So you wrote it as 6x cubed, begin with the one with the leading power, and then you say 4x squared minus 2x squared plus x minus 6x plus minus 7 minus 3, right? Because the one that the it's a subtraction, so all of the terms in that parenthesis of 2x squared plus 6x plus 3 will have change in signs. Okay, that will now become minus 2x squared minus 6x minus 3, and so that's it. Your final answer will be 6x cubed plus 2x squared minus 5x minus 10. Good. All right. Do the next two, and then after that, you can tell me your answers. Yeah. So sometimes when we give problems, we just reshuffle all those towers.
Is it 3x5
Mm-hmm.
plus x cubed
Okay.
minus 2x squared?
Oh, but there's a 3x squared there. There's a 3x squared in the first polynomial.
Minus x squared
That's 3x squared minus 2x squared.
plus x squared
Okay. Yes.
plus 10x plus 3.
Okay. Yeah, let's wait for the others. Yes. Okay. Yeah. Okay, so has everyone done this? So you got, okay, yeah. Yes, I think Manish said 3x to the fifth plus x cubed plus x squared plus 10x plus 3. Did you get that?
Yeah.
Yes.
Yes, good. Nice. All right. Okay, next. Got the. So
I
always remember to write your final answer in its standard form. Powers are decreasing.
I got I've done the third
Okay,
one.
what
Can I
did you
say
get?
it? 11x cubed plus x squared
Okay.
Manish, how are you?
minus 6x
Right there.
All right.
plus 8.
11x cube. Are we okay?
Yeah.
Yeah, because we now have 3x cube minus 8x cube.
Mm-hmm.
Yes. So anyway, just sometimes it's just good to do this first before doing anything. Plus 3x cube minus x plus 6. And then remove that minus and change all the signs. So that, yeah, but you can do it. But sometimes, you might forget to do that. There. So sometimes it's easier to first put them in one line without those parentheses. Okay? Especially when there's a minus, because you'll have to change the signs of the ones inside the parentheses. So final answer will now be 11x cubed
11
plus,
cubed.
yeah, because you now have 3 plus 8, okay? Plus x squared, because you now have a 5x squared minus 4x squared, okay? And then you will now have minus 6x, because that is minus x minus 5x, right?
Mm-hmm.
Then you now have 6 plus 2. Good.
Plus 8.
Nice. So I think the next we will be dealing with all polynomials and until the beginning of the class on Thursday. So yeah, so I think that one is fine combining like terms. Now let's do multiplication of polynomials. Okay, so again, the combining like terms will be there. But in multiplication of polynomials, we'll be using the property of real numbers called the distributive property. Okay. Where we now distribute the term of the first polynomial to the term of the second polynomial, and then we do the multiplication. All right, so the distributive property. Just an illustration here. If I have 2x plus 1 times 3x squared minus x plus 4, I distribute first the 2x multiply by the second polynomial, and then plus 1 multiply by the second polynomial, just the same. Okay. And of course, the rules of exponents will be used. So all of those rules that we have discussed previously, we should be remembering in order to do this multiplication thing. So when I distribute there, so you now have 2x minus 2x times each of these terms plus 1 times each of these terms. This is just, of course, a review on your part 2. I've done this before. So 2x times 3x squared is 6x cubed. You multiply the coefficients and add the power of the variable. 2 times minus x, 2x times minus x is minus 2x squared. 2x times 4 is 8x. And then, of course, this is multiplied by 1. So you get 3x squared minus x plus 4. And proceed to your addition or subtraction. So, of course, combining like terms, have 6x cubed, the minus 2x squared plus 3x squared, 8x and a 4. And your final answer is 6x cubed plus x squared plus 7x plus 4. So it's just using the distributive property. Okay, so I think now you have done this and you know that you have remembered what had been done previously. Okay, so let's just have one or two examples here that we can work on. X cubed plus x minus 5 times 3x plus 4. So actually you can just yeah. So you say I multiply each of this and this and this, that. Okay, and so you just keep distributing. So you really don't need to do the very detailed thing that I have shown a while ago. You can just say you multiply one by one each one. Okay, can we just do this together? So what will that be? Before we combine like terms, so x cubed times 3x is 3x
3x
to the fourth, right? X cubed times 4,
4x cubed,
4x cubed. X times 3x,
3x squared,
3x squared. X times 4,
4x
yes, minus 5 times 3x,
minus 15x,
yes, minus 5 times 4.
20 minus 15,
Final answer,
3x cubed
now you begin with the
plus
4.
4
Okay, 3x to the fourth
plus
plus
4x
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 cubed plus,
plus
just
3
happen that they are all just 1 each, then minus 4x minus
11x
15x.
negative 11x.
Yeah, right. Minus 20. Yes. Easy. Okay, yeah. Do the second one. Oh, I hope I'm so that sometimes it may not be clear. X squared minus 3x plus 5 times 4x squared plus 7.
I did already. Can you check?
Yes, sure.
4x to the fourth
Yeah.
minus 12x cubed
Okay.
plus 27x squared
Okay.
minus 21x
Mm-hmm.
plus 35.
All right. So let's wait for the others before I write the final answer. Okay, so everyone has done it too?
I've done it.
Yes. Okay, so I think everyone, we now can give the final answer. That's 4 X to the
X
fourth
to negative
minus
12x
12x cubed.
plus
plus
27x squared
Yes.
minus 21x
Okay.
5.
plus, yeah.
Very nice. Okay, I think we are doing well. So we'll see. Okay, now this time, I hope you still remember this FOIL, multiplying binomials. Yeah. So it's called FOIL because it says, see, this time it's just binomials, yeah? Multiply the first terms, then the outer terms, then the inner terms, then the last terms, add the products, combine, and simplify. So first, out, then inner, and then last. Okay, yeah, so it's just like that. So the first is when I have 8x plus 4 times 2x plus 5. So you'll first have 8x times 2x. That's the first. That will be 16x squared. All right. And then we now have the outer 8x times 8x times 5 is 40x. Then the inner, okay, 4 times 2 is 8. And 4 times 5 is 20. And then most likely the ones that are the inners seem to be in a situation like this would be the ones with like terms. So you'll now have 16x squared plus 48x plus 20. And of course, you also can just do in any way, but one nice thing with the FOIL is that the ones that have the same terms, the like terms, they are already put together. So we'll now have first, outer, inner, and then the last, the last term of the binomial. Okay. Yeah. So mathematicians, you just would want to. Right. So that's the same. And have 7 times 2. Okay. And then outer. Okay. 7 times 4. Inner, and then last. Right. So immediately, actually, you can just say, you can do your mental math there. Then you'd have 14x squared. And then I have 28 minus 6 is 22. And then 3 times 4 is minus 12. Okay. Just to make it shortcut kind of thing, yeah? 7x times 2x is 14x squared. Then you will say 7x times 4x minus 3 times 2x is 22x. And then minus 3 times 4 is minus 12. Okay. Let's do that.
Yeah,
Yes? Question?
what difference does it make?
Say that again.
What difference does it make to do outer out in
Oh, no.
than doing
Actually,
like
it doesn't really make a difference. The only thing this one is a good thing is because you know that the terms that are like are already put side by side. So it's just easy to combine, Because there are times when you get confused that, that other one, you put it somewhere else, then you combine something that should not be combined. So that's the only thing, all right? So that by using your mental math, without even doing that by longhand, you can immediately give the answer. So that like you have 9x minus 4 times x minus 6. So what you do is just 9x times x is 9x squared. And then just multiply 9x minus 6 and 4 times x would be the same terms, okay? Yeah, so that the 9 times 6 is minus 54 minus 4x, it will become minus 58x. So it's like a shortcut kind of thing, but really it doesn't make a difference. You can do it your way as long as you are using the distributive property. Okay, then that would be fine. Okay. So can we answer this without even writing?
9x squared minus
No, I say without, you just write the answer, okay? Without putting in the working, okay?
Yeah, it's
Yeah,
possible
you
to do
can
this
do
in
that, right?
practice.
Yeah. So you know that, yeah. So you're saying 9x squared. Okay. I'm sorry. I will change my highlighter to my pen. Okay. I'll say that loud. 9x squared.
9x squared.
Then the middle term. What will be now the middle term? Sorry for my squared. Okay.
Minus 58x.
Okay. So minus 54 minus 4x is minus 58x. So that's now the difference because using the FOIL, you know, is easy to get the answer. Okay. And then plus
24.
24.
24. Yeah. Okay. That's great. Oh, can we do the second one?
Minus 5x squared.
Okay.
Minus 19x.
Okay. Yes. Yeah,
Plus
because you now have minus
30.
25x squared minus 25x plus 6x. Okay.
Mhm.
Plus
Plus
30.
30.
30.
Very good. So that's with FOIL. Shortcut. Oh,
Mhm.
the ones, my ladies,
You,
you be the one to give me the answer for the third one.
X
X
X
cubed
cube, yes.
with X
4x squared
Okay.
negative 8x
Yes, in this
minus 30.
situation, they are all different. But one nice thing with this is you are already having your answer in its standard form. Okay? So you now have x cubed plus 4x squared minus 8x minus 32. That's one thing with FOIL also. So that when you put your answer, it's already in its standard form where your exponents are reducing, decreasing. Okay. So I think that's the beauty of FOIL.
Mhm.
X cubed
Okay.
Minus 3x
minus
squared
3x squared
Mhm.
plus
10x
10x
squared,
squared.
which is 7x.
Yeah,
Okay,
this
which
is
is
in the very
7x squared. Very good.
and then
and then
minus 30.
negative 30x.
Minus 30x.
Minus.
30x.
No, you start with the x cube.
Oh, we begin with x cube, right?
Yes.
Yeah, we did.
Okay. Yeah. Okay. Okay, let me erase this first. We begin with x cube, correct?
X cubed plus
Then
7x squared.
Okay, x
mi-
cube plus, sorry, 7x squared. Why is my writing like this? Okay. Yeah. Minus
Minus
30.
30x.
X, yes. So x cubed minus 7x squared. Sorry for that. Minus 30x. So that's it with FOIL. Huh? So I hope, but the principle remains the same. It is still distributive property. Okay. All right. So that one last thing on perfect square trinomial, and then yes, we still have just about, for the next 5 minutes, this one is squaring a binomial. So now I just want to repeat the one what we did previously, that the squaring of x plus a squared is not just x squared plus a squared, all right? But rather, okay, if you square a binomial, it is squaring, is the only ones with the squares would be the first term and the last term, but there should be a middle term. And the shortcut kind of thing is the middle term is twice the product of the first and the second. So that's another shortcut. Well, of course, we can do it's actually because you have x times x is x squared, x times a is ax using FOIL, a times x is ax, and that's twice ax, and then a times a. So when you have a binomial and you're squaring, it's just a matter of square the first, twice the product of the first and the second, and square the second term. And that's it. You already get the answer. Right. Let's do this. Okay. So just for sorry. All right. So what's your answer for x plus 5 times x plus 5 or x plus 5 squared? By just following the
X.
rule. But of course you know where we got those. What's the answer?
It's x squared
X squared
plus
twice the product of the first and the second. So actually you don't even need to put this one. Okay, you just look at x plus 5 squared. So you now have x times
Then
5 is 5x and
X
is it 10x, right?
yes plus 25.
Very good. All right. Okay. This one?
X
Easy.
squared
Yes.
plus
Minus
Minus. Now it's minus. All right. So whatever is the sign of the sign of the middle term must be the sign of your whatever is your sign for your binomial. Minus.
minus 16x
Yep. And then that will be a plus. The one at the end will always be a plus. So there will only be
plus
changes in the sign of the middle term depending on the sign of your binomial. Yes? 64.
64.
Very good.
Mhm.
Oh, yeah. Say that immediately your answer. Easy.
X squared plus 2xy plus y squared.
Very good. Okay. Another person. Yeah. So each one should give the answer. Okay. I'll excuse you, Manish, in answering because you had been answering a while ago. Okay. Number 2.
Me too.
Yes, Abigail. Yeah. Okay. Yes. Number 2.
X squared minus y.
Okay. What is x times 3y is 3xy and double it.
Is
Mm.
6xy
Yes.
Yeah, minus xy plus 9y.
Squared. You're squaring 3y times 3y.
yes
Yes. All right. So x squared minus 6xy plus 9y squared.
Why are we squaring the y?
2y
Yeah, because it's 3y times 3y.
3y times 3y.
I know,
It's
but
like y times y.
but do you? Yeah.
Y times y is
Yes.
y
All
squared.
right. 3 times 3 and y times y. Okay?
Mhm.
9y squared. Good. Let number 3. Who has not... what's the answer for number 3?
Mhm.
Okay, I'll give you some little 2 seconds to think. Anyone?
2b squared.
Okay, and what is 2b squared? 2b times 2b. That will
B
now be
squared.
4b squared, right? Because you
Uh-huh.
multiply 2 times 2 and b times b. Okay, then plus
16.
okay, so that will be 8bc and multiply by 2. Good. 16
C squared.
bc. Yeah. Right? Just bc. Why is my writing like that? Okay. 16
Then
bc. 2b times 4c is 8bc. We are multiplying here. So you are combining, not the like terms or whatever. It's multiplication. So 2b times 4c is 16bc. Times 2, I should say. Is that okay? 2b times 4c is 8bc times 2. And then what will be the last term?
16c squared.
Very good. Yes. Okay. The last one.
16x squared
Yes. Mm-hmm.
minus uh 40,
Times 5 is 20 times 2.
is it 40
40, yes.
xy
XY, yes. So
plus
the last
Yes.
term will always be a plus, okay?
Plus
25
25 squared.
y
Y.
That's what I
whole.
meant. Squared.
Very good. All right. So I think we're okay. We're doing okay. Yeah. So we'll be talking more and then we'll learn how to divide and then we'll end the chapter and we'll move on to the real thing. Okay. Yeah. So as I mentioned, what what would you prefer? The quiz be done at the beginning or at the end so that when you're done, you can go?
Yeah, I think
At the end.
I was thinking to do the quiz at the beginning because then we have the rules in our mind and then we don't have the new rules in our
Okay. So
mind.
that you will not get confused because I will still discuss.
But
Okay.
that was my thought for
So how about the
everybody
others?
else.
So we'll
That
agree
works.
because me, I want that everyone is comfortable.
Yeah.
Yeah,
Yeah.
like start with the
Yeah.
quiz, then you.
Oh,
Yeah.
let's start at the beginning, and I will.
Mhm.
What I'll do is I'll work on a quiz, and then the number of minutes I work on it. I will give it to you 3 times the number of my minutes, so that you will have enough time to do the thinking and the writing. All right, so that's it for next meeting. Okay, we'll have a short quiz first, then we'll move on with the rest of the discussion. So have a great day, enjoy your lunch and your afternoon. All right.